Okay, just going off the latest subject report, they're starting to get very picky and looking at almost perfection. So, your textbooks don't really go into anomalous versus outliers. So, I'm just going to do it here. Um, you've really got to now be very specific about these terms, and you can't just say that a point that doesn't look right is anomalous. Um, you have to be able to tell the difference between whether it's anomalous or an outlier. So for an outlier, even though your syllabus says you don't need a mathematical justification, it's actually far easier just to do that because then your justification is very clear and easy to do. So I do have videos on how to do percent difference. It's a very simple thing in Excel. And in so outliers are random errors, and so in that I also talk about Westgard rules as another way to tell that it's an outlier. And so outliers are to do with precision. It's a random error. It's just a mistake. It will distort your data, so you will need to get rid of it, and you do need some sort of justification for that. And so basically, that's what outliers are. Now, anomalies are slightly different. They are not mistakes. They are actually just you not getting the relationship that you thought you were going to get. And you can't just say, oh, it's because it's a mistake. You have to have a careful analysis of it. It could be a systematic error due to do with accuracy. So anomaly is related to accuracy systematic error, whereas outliers are more random error precision issues. And so just you need to just look at it very, very carefully and think what in my method was a systematic error that caused that, or what in the chemistry might be explaining that there's something else there that I need to discover. And so a good example of this is, of course, you'd expect as you go across the periodic table that the boiling point would increase because it's heavier. But you don't get a nice straight line. You get this curve here because you haven't considered Posnag attractions as well, intermolecular forces, not just molecular weight. And so that's not a mistake. That's just a fault in your thinking of what the relationship should be, like this blue one here, and it's not. So you have to investigate it further. That's an anomaly. All right, not a random error. It's not a systematic error either. Okay, I hope that's helpful.